Hi, good afternoon, everybody, and welcome to my Planetarium Show for May of 2021. Let me just get this going for you. So here we have the screen showing the view that we would have in the afternoon of the middle of the month, May the 15th. And this is generated using software called Stellarium, which you can download and play around with yourself for free. It's absolutely fantastic. Well, I'll get the show going, and what we'll do, as usual, is follow the sun down towards the horizon as time moves swiftly forwards towards sunset. So we'll let the time run faster than normal down to, and the sun will sink down. Here we go, the horizon coming into view now, until around about 8 o'clock in the evening, at which point the sky will begin to get dark. So we'll see the initial colours of sunset coming in now, the sky turning that orange yellow colour, finally turning a deeper red. And the sun just disappearing there now. And the first object that we're going to take a look at is the Crescent Moon. Just the thinnest possible crescent at this particular date, and you can see the very thin sliver illuminated there on the side with 1 or 2 stars in the surrounding sky. Just on the daylight side of the moon there, Mare Crisium, the Sea of Crises, that large round impact basin. Also visible in this shot though, we've got Mars. The moon and Mars are very close together on the May the 15th. So easy to find. If you can find the moon, you can just swivel left a little bit and you'll see the red planet Mars. Here's a magnificent view of it that you would get through a decent, powerful telescope, showing the disk of the planet getting a little smaller now as it's getting further away from the Earth. And we've got the 2 moons there, Phobos, which has just disappeared behind Mars, and Deimos. So if we swing in and close in right up tight on Mars there, you can see some of the desert regions in rusty coloured orange, and the darker highland regions, and a large volcano, and as well as, of course, the polar cap there up at about 2 o'clock on the screen. So that's the disk of Mars as you would see it with a powerful telescope. We'll pull back away, again showing the Crescent Moon, and now the Milky Way is just about visible in the sky as well, just below the moon there. But we'll let time run forward till 10:15. 1 or 2 satellites whiz across the sky. A whole train of Starlink satellites there for a moment. So now the sky should be properly dark, and we should see all of the night sky in its glorious detail. As we go on into the summer, we do have to stay up later and later to really get that. Now, the first constellation we're going to look at tonight is the constellation of Leo the Lion. Here's the stick diagram, and it actually looks fairly similar to a lion, in my opinion. I can make that out. There's the graphic to show you how it's supposed to look. We'll take that away, and we'll zoom in on some of the very lovely to look at groups of galaxies. Leo has got several groups of galaxies. Here's a little cluster that we can find. They're Messier objects number 95, 96, and 105. And you can find them quite easily with a medium-sized telescope. You zoom in here, let's have a look at M96. Very interesting shape, almost a double loop to this galaxy, isn't there? In the outer regions surrounding the main spiral structure. But we'll move along a little bit now and look at M105, and it's more of an elliptical galaxy with not very much obvious structure, but it does have those 2 companions. So there's 5 galaxies to find in this little group, just underneath the front paws of Leo. And these are around about 35, 36 million light years away from us. So they're not part of our little local group that extends for about 3 million light years. They're about 10 times further away. This is the famous Leo trio, the triplet, and this is M65, 66, and NGC, New General Catalogue, 3628. Didn't get a Messier number, which I'm quite surprised by. So the two bottom ones there are the Messier objects, but this one is NGC 3628, very much a side-on view showing the magnificent dust lane and possibly some sort of jet coming out of the middle of the galaxy there at the bottom, down towards that bright field star. Slightly warped shape as well, so the other possibility is it's undergoing some sort of galactic collision. Now, if we slew over to the nose of Leo the Lion, we have a lovely barred spiral, the Catherine Wheel Galaxy, as I call it, NGC 2903 in the catalogue. And again, about 36 million light years away. Lovely spiral arms emanating from the ends of the bar there. So that was Leo the Lion, very much the realm of the galaxies. There are many more galaxies to find in this part of the sky, as we shall see. We'll now move on and we'll just pull back. You've got the Moon and Mars there in the bottom right-hand corner, and the twin stars of Castor and Pollux in Gemini, which is hosting Mars at the moment. But we'll slew to the left of Leo and we'll let time run on to midnight. I'm going to concentrate on one or two slightly less well-known constellations. Again, lots of satellites, particularly the Starlink satellites whizzing across. Next door to Leo, we have Virgo, again, the realm of the galaxies. This larger constellation covers quite a big area of the sky, but has this very prominent bowl up to the right here. There is Virgo herself lying sideways, holding a bunch of flowers and some palm fronds, I think it's supposed to be. But if we zoom in just in the bowl, in the region between the tail of Leo, this really is where to look and go galaxy surfing. We have the Virgo cluster and the Markarian chain of galaxies, this whole row of galaxies. And the more you look, the more you see here. We've got the obvious bright galaxies, but there are lesser, smaller ones all over the field of view. Can't go naming them all, but well worth having a look. You can hardly move for tripping over them. They're around 50 million light years away, so a little bit further. And one of them, M87, the giant elliptical that we saw in the middle of the field of view, is the one in which astronomers imaged the first ever picture of the accretion disk around a black hole a couple of years ago using the Event Horizon telescope. But just above Virgo is a lesser known constellation that consists basically of these three stars called Coma Berenices, Bernice's hair. It's supposed to be just a bunch of hair tied up with a ribbon. Rather a curious thing to choose for a constellation. But I've chosen it for tonight because, again, it contains some interesting galaxies. Here's the Black Eye Galaxy, a little bit nearer, 24 million light years. And you'll see why it's called the Black Eye Galaxy. Looks like someone's punched it in the face, doesn't it? Quite interesting. And you really can see it like that with a 6 or 8 inch reflector telescope because it's relatively nearby and quite bright. So well worth looking for. That's the Black Eye Galaxy. So pull back out again to the constellation of Coma. And the other thing that makes Coma very famous is the Coma supercluster. If you thought there were a lot of galaxies in Virgo, this is the Coma supercluster, and it is absolutely stuffed with them. 10 times further away than the Black Eye Galaxy, 250 million light years. So very much on the limit of an amateur telescope. But if you can track it down, there are dozens and dozens of galaxies in that large cluster. And it was studying that large cluster that led Fritz Zwicky to first suggest the existence of dark matter back in the 1930s. Rather nearer to home, we've got the globular cluster, Messier number 53 here. And you can see another cluster just to the left there. So if you find M53, you can slew left and see the rather more open cluster. So quite a good contrast between the two of them. So I'll pull back from there. And the next object in our tour of the night sky is going to be much later. We'll let time run forward. So that was midnight. So we're going to run it right forward to just before dawn now. One thing you can see here that's worth looking at with a pair of binoculars, and I should use the pointer, this grouping here, this is the Melot 111 cluster. It's a very large structure containing many stars. You can just about see it with the naked eye as a misty patch if you have very clear skies, but binoculars show it really well. It's about 5 degrees across, so a telescope tends to just see it as a few stars scattered around, and you can hardly make out the size of it because you've drilled too far into it. But the reason we're stopping at 5:40 in the morning is because we've got some planets to look at. Here's Jupiter, the largest of the planets. This is what it would look like with a 6-inch reflecting telescope, the planet with the cloud belts across the middle, and the 4 large moons discovered by Galileo, laid out in a line there, 2 on each side. They change their position hour by hour. They orbit round quite quickly, so it's worth looking at the beginning and the end of your observing session. We've zoomed in a bit on the planet here. You can see the great red spot and the cloud belts in more detail, and some of the lesser spots there in the southern belt, this white coloured markings on the surface. So there's the king of the planets, Jupiter. Now we're going to have a look at some of its moons. I'm going to start with Io, the innermost of the large moons. This always looks very yellow in colour to my eye, and the reason is it's covered in sulphur. All these colours we see here, the black, the yellow, the orange and the white, are all different forms of sulphur on the surface of Io. It's the most volcanic world in the solar system, turning itself inside out almost with huge eruptions. But we're also going to now take a little peek at this little tiny moon, Amalthea. This is the 5th largest of Jupiter's moons, a small, almost sort of captured asteroid size moon, much tinier than any of the 4 large Galilean ones, but it's just about detectable with amateur equipment. We've picked it up a number of times at the observing sessions that we do at the Cambridge University Public Observing. Second moon out from Jupiter of the Galileans is Europa. Fascinating because it's covered in ice, which has these grooves or cracks in the surface that's letting some sort of organic material escape from a briny ocean that's kept warm by geological activity underneath the surface of the ice there, a protected habitat possibly for some form of alien life. Highly probable in my view. The third moon out, the largest of the moons, in fact the largest moon in the solar system, bigger even than the planet Mercury. This is Ganymede, and has a mixed surface, 1 or 2 impact crater scars there, but lots of glaciers and a fairly young and active geological surface, again possibly shielding an underneath the ice ocean layer. So again, potentially habitable. And 4th of the moons is Callisto. This orbits further away from Jupiter and is less affected by the tidal effects of Jupiter's gravity. So it's dead geologically and has accumulated numerous impact craters on the surface that aren't being rubbed out by all of the volcanoes, the geysers and ice flows that occur on the other inner moons. So that's a quick tour once around the moons of Jupiter, as we say. Now we'll have a look next door at Saturn. You can see it already in the same image here. It's the bright object just to the right of the center of the screen here. And we'll zoom in on that. Jupiter has just overtaken Saturn, passed by, and we'll pull away from it. But this is what it would look like with a small telescope. Of course, you wouldn't have the labels indicating which moon is which, but it's great fun trying to identify them from looking at stellarium and then looking at the telescope and seeing which is which. Of course, you've got to remember your image might be upside down or backwards, depending on how many mirrors and prisms you've got in your optical train. But this is Saturn in all its glory, zoomed right in with the cloud belts, the shadow of the planet on the rings there that gives you that 3D effect, and the structure within the rings with the Cassini division, the dark gap between the A and B rings there. Now moving out to its largest moon, Titan, again about the size of planet Mercury. So a very interesting world in its own right, covered in thick, smoggy atmosphere that's 1.5 times as dense as our own and full of all sorts of interesting organic molecules, carbon, hydrogen, nitrogen compounds called tholins, potentially the basis of the chemistry of life in the atmosphere of Titan. And I'm afraid that's all we've got time for this month. So we're going to bring the sun up and let the stars fade out. Thank you very much.